Now that the servo motor has been added and we have seen it working, we will now set up a simulation of the motor, and we will get some results from the simulation. So the motor itself here, I set it up like this here. It's angular velocity, 30 degrees turn each time, and set it up to measure velocity. And it's okay. And what I will do now is set up measures here for the analysis. And I'll take these two out. I already have them in here. So I will create a new measure. And what I'm going to do is I'm going to use the type of measure is going to be a position measure. So I'm actually going to use these points that I already have here on the model. So this point was used as the starting point for the spring. So I select that. And so that's my first measure. Let's say OK to that. I leave the name as it is, measure 1. And I'll add another measure. And this will be 0.2. And I accept those values here. So I can close this here. And now I will set up the mechanism for the analysis. I'm setting up as position, and I will start I'll run it for say 20 seconds. And I'll just run the simulation and I'll see what happens. And that's enough. And I say OK to that. So then I go back into my measures here. And you see the analysis I ran there is called analysis definition 2. So if I just click on the analysis definition and say measure 1, and just look at the result I got here. So measure 1 is set on that point there. So that is what I'm getting here. If you can see here, it does make sense. It's tracking the movement of that point here axially along this shaft here. So it's at that point there, and then when it's activated by the cam, the fork here and the point which is on it is displaced by that amount there, and it returns then, the spring returns it back into position when the cam is released. So that is a measure, that's how it's done. We're not doing anything serious with it, just showing you how to do it. So if I close this one here, I should have closed that actually. Just I look at measure 2. Now measure 2 will be different because that point there doesn't actually move. It's not activated. So I just click on the analysis and just click on the graph, see what it produces, and you can see that it doesn't move. It stays in the position it is, which is about 310 or whatever it is millimeters away from where it was defined. So that's that. And if I just open up the measures again, that's the measures I use there. Now this kind of thing can be done to use all types of analysis, displacement, speed, etc. And it's used for the design, kinematic design of mechanisms like this here. So that's, and again here it's showing the current position of the point here along this continuum here. It's at 199.609, and it probably moves to about 250. This one doesn't move at all, 315. So that's how that works. So that is the analysis, and then that analysis then can be saved and can be printed as a PDF, etc. And so that's pretty much it. So I'll close this here and I'll update the model. And my old friend, the regenerator, is working. So I'll regenerate it again and save again. So that is that more or less that lab completes